Hello, everyone. James here. Hope everyone's doing all right. So I'm essentially going to switch gears a bit and get into a bit of science topics. Again, the science dynamic is very broad and it goes into different topics for kids. But for this one, I'm just going to speak on the experimental phase, the scientific process, and I'm going to give the processes and go through each process. So, just for simple terms, the scientific method is a process for experimentation that is used to explore observation and answer questions. As we go through the steps, try to think of something that you have observed in nature but had no answers for. Scientific method is actually composed of six processes, and they're never in order. Sometimes it's one over the other, but nonetheless, the structure is meant to be able to um, critically analyze the questions being asked and justifying it with the experiment that supports what you're trying to get answered. So first we have the question and research phase. That's where you ask the question and you support it with some of the research, a bit of research to kind of justify what your what your conclusion is to that question. Essentially, after that, you go to the hypothesis. Hypothesis would be based on an educated guess. Say you had a question, you did a bit of research, you come up with a reasonable solution, a reasonable answer to the question you initially asked based on a bit of research, a bit of background information. Now, then you get to the experimental phase, and in the experimental phase is where you utilize some of the things that you brought up in your research and using that to answer the question you initially asked that essentially created the hypothesis. So the experimental phase would just be you justifying the hypothesis. You see how the steps are in this in the manner. This is kind of like the base foundation of how everything builds on itself. But in certain dynamics, you can actually switch each process. But once you're at the experimental stage, it's it's very important that you observe that you take into account some things that are going to matter in the next couple of steps, like making sure you observe in the observation stage. You're pretty much looking at what's happening in the experiment to support the hypothesis you initially had. And then in the analysis phase, you're using the numbers. This is where the numbers actually come into play. Observation is just kind of like qualitative information compared to the analysis stage, which is more quantitative, meaning one is more number based, while the other one is more just um, idea based. And in the conclusion, that's where you bring everything all together using the hypothesis. At this point, the question and the research phase is redundant. It just repeats itself, and so you just use the hypothesis, the experiment, what you observe, and your analysis to justify the initial question you had. So in some cases, let's move this here. Beginning the question. The question section of the scientific method is where us being scientists propose or determine the problems we want to solve. In some cases, the question leads us to the hypothesis, which is defined as an educated guess to the questions asked. The cases in which question is answered by the hypothesis would then take a step further by experimenting. So basically, what this slide is saying is we have a question. So one of the questions that we could think of is why are cars shaped a certain way? Now, for us to be able to create an hypothesis, we have to do a bit of research to why cars are made a certain way. And one thing that we'll notice is that cars are built a certain way is due to the one, fuel efficiency, meaning the power the car is going to be using to get from one place to another, and the speed. Cars are shaped a certain way because it's easier for them to beat air resistance and to going further. Those could be some of the background research we've done. And saying that, we then create an experiment to try to justify that kind of scenario. All right. So in the experimental stage, the idea is to conduct ordered investigations that are intended to prove or disprove a hypothesis. The experimental stage is where we, the scientists, have to make sure we are paying attention so we could jot down our observations. The observation stage is where statement of knowledge gained through the senses or through the use of scientific equipment is accounted for. So regarding what I was thinking of why cars are shaped a certain way, This would be the experimental stage. What we could do would be us trying to just compare two cars, a big bulky truck looking car to a sports car, a Camaro type sports car, right? In this situation, this would be the experiment. Experiment would be pretty much we're looking at the shapes and we're comparing the power consumption for each car from for them to get from one place to another. We're looking at the time it takes for them to get from one place to another. And in saying that, the observation stage is very important because this is the stage where we actually start noting down what we observed. Which car is making a louder noise? Which car finished first? What are the shapes of the cars? What's the shape of the car that won? Right? Tying it back to the initial question we had. So basically, when the experiment has been established, we then go back to the observation, which is essentially us saying, what do we see? What do we sense? What do we hear? We hear the power. We could see that one finishes faster at a specific time. We, in this situation, we're actually using our senses and we're using some scientific equipment regarding either we're using a ruler to measure from one place to another with a timer or a clock, a stop clock, or we're just kind of listening to see which engine is making the louder noise in regards to trying to get from one place to another. So in the analysis stage, the scientists compare the results of the experiment from observation to prediction posed by the hypothesis. Once the analysis and observation have been compared to the hypothesis posed from the question asked, we then have to make a conclusion that is supported by the experiment. In the conclusion stage, this is where we as scientists make a statement of whether the original hypothesis was supported or refuted by the observation gathered. So basically, in the observation stage, that's where we're doing the qualitative information. We're getting the qualitative information, which is just based on what we see, what we're timing. Now, the analysis phase is where the numbers actually matter, right? The number, when we say qualitative and quantitative, qualitative, quantitative is essentially where the numbers play a part, while qualitative is just kind of like observation, things you see, the ideas behind certain things. So in the analysis phase, this is where we're looking at the stopwatch and we're looking at the time it took for it to finish. This is where we're looking at the power consumption of the motors in each car to see who's actually from one place to another, which is actually exhausting the most power, which is using the most power. Now, when we actually get all those information together, we then write a conclusion. The conclusion is going to be based on what we've observed. If you remember the initial question I was asking, and I hope you were asking certain questions also. The initial question I was asking is why are cars shaped a certain way? And saying that, we look at a bulky truck looking car to a sports car like a Camaro. And to conclude, we could see that one car was going faster than the other within a specific time range. We see that one was also consuming more power than the other within a specific time range. Now we tie it back to the hypothesis we had, which was cars are shaped a certain way because it's due to power consumption and also defeats air resistance, which allows it to go faster. So in saying that, we kind of just tie everything back together to the conclusion from our hypothesis to our experiment to our observation, a qualitative observation, and then the quantitative, which is the analysis phase, which is number specific. Then we conclude. So was I right based on what I said, what I've asked, and the way I did my experiment justify my question? And that's what everything comes down to in this conclusion phase. Again, the science method, the science within eighth grade is very elementary to an extent, but I'll definitely try to dive into it more and see which topics are up there in regards to confusion. Again, thanks for joining me. Go ahead and hit that like button, subscribe, and I'll definitely try to come back with more good content. Thanks again for joining me. Bye for now.